Today's smartphones and tablets can all run sophisticated software applications. Each have their own operating system that determines what applications can be run on each of them. Now, this tutorial looks at common hardware platforms that exist for desktop PCs, laptops, and smaller mobile devices such as phones and tablets. So we're going to start our discussion by looking at components of a typical computing device. At the very lower level here, we have the hardware. And one of the most important things is what central processing unit or CPU the hardware is going to use. So we'll look at different types of CPUs that support different platforms, whether it be a desktop or a phone. After this, we have the operating system, the OS. Now, sometimes the OS you can think of as having a couple layers, and the bottom layer is sort of the core OS service, sometimes called the kernel. Sometimes it's also called the hardware abstraction layer, or HAL. It's that part of the operating system that communicates directly with the hardware, whether it be the CPU or the video card and so on. And the remaining part of the operating system services sit on top of this. At the very top is the application, and the application has to be written for a particular operating system. So you can't run an application designed for a Macintosh operating system if you have a Windows operating system here. Finally, the user is going to interact with the app through the graphical interface or graphical user interface. So using a keyboard, mouse, could be touch, they interact with the app. So those are the three basic components of any computing platform. Now we're going to look at the typical desktop platforms that have existed for a while, and we're going to look at a few different CPUs that are on the market that form the basis of the hardware platform. So Intel make probably the most popular CPU, and today it's called the Intel Core series. A few years ago, Motorola had a few CPUs that it used, and they were given the name G3 and G4, and these were called Power PCs. Higher end for workstations, people that did 3D CAD and animation were trying to use even more powerful CPUs, and they were based on a technology called RISC. And such a CPU, and there were others, is called a SPARC CPU or SPARC processor. Now, on each of these CPUs, various operating systems existed. So in the Intel Core family, we typically have Windows. And we have a few different, obviously different versions, but you can have two main types of Windows. What's called 32-bit Windows, which is designated by x86, or the 64-bit version of Windows, we won't go into that now, which is called x64. But there are many other operating systems that ran on the Intel Core, which we'll look at a bit later. In the workstation or sort of powerful desktop PCs, typically some version of Unix ran on here. And in this case, in the SPARC case, it was a company called Sun that created an operating system called Solaris. They have since been bought out by Oracle. And we would have on top of here our apps designed for Unix. For the PowerPC G3, G4 from Motorola, this is what OS X started to be based on. And OS X at its core has Unix as well. So we can think of this as OS X residing on top of a Unix core. Now, as things evolved, companies wanted faster and faster processors, so this gave way to an even faster processor created by IBM called the G5. And so OS X was designed to run on the IBM G5 processor. And again, we have apps here designed to run on this version of OS X. At this time as well, laptops were becoming more and more important, so mobility was important, and with mobility, batteries were important. So we wanted a bit of a shift from performance to something that had performance and battery life. Apple found out that the G5 from IBM had good performance, but consumed a lot of power, couldn't work very well in battery applications. So they eventually dropped the G5 and they ported their entire operating system to the Intel Core family of CPUs. And what this meant was that they had to modify their operating system and redesign their apps. Put a little star. So they're still OS X apps, but now they're designed to run in an operating system that's designed to run on the Intel Core CPU. So this was the desktop landscape, and to this day still is the landscape for Windows desktop computers and OS X. We're now going to look at phones and tablets, and really I guess you could think of the developer of the smartphone, or the company that really made the smartphone take off, was Apple. Apple looked around and found that the Intel Core CPU simply burned too much power for something that was going to be used in a small mobile device like a phone with a small battery. So they looked at a different company called ARM Holdings. It's a British company that produced a CPU that anyone could license, and this CPU had the best performance and battery life or efficiency that happened to be on the market. Since they licensed their designs, other companies could buy or pay a fee and modify that design and then manufacture their own CPUs. So this is what Apple did. So Apple produced an ARM-based CPU, and they just denote it as A. I assume A for Apple. So they have the A5 and the A6 currently out. And they use this CPU as the foundation for a new operating system. But they did base this operating system on OS X, but it was significantly different. Significantly different because it was designed for touch as opposed to a mouse. And they called this operating system iOS. And now to run applications on it, you need to have iOS apps. And they created an app store where you could purchase iOS apps. But these iOS apps do not run on OS X. They only run on iOS mobile devices. And the devices typically are the iPhone, the iPod Touch, and the iPad. Now, there are other companies who were looking at doing the same thing, and a company called Qualcomm also licensed ARM technology to produce a CPU based on it. They called it Snapdragon. These are the CPUs that Android from Google used as the basis for their operating system. And Android are on such smartphones from Samsung, LG, and from tablets. So here we need Android apps which can run on these devices. Microsoft has come out with its own phone system, and they've called it Windows Phone 8, and it's also based on the Snapdragon CPU, which again is a derivative of ARM. So you need a Windows Phone 8 app in order to run on the Windows Phone. Now another company has gotten into the market and also licensed ARM's technology, and it is NVIDIA. And it's produced a CPU called the Tegra. And this CPU is the one that is in Microsoft's tablet, or one of Microsoft's tablet, because they have two tablets. It is used in the Microsoft Surface, but the Surface, which uses what is called Windows RT as the operating system, and we're going to talk a bit about Windows RT. And we're going to talk a bit about the apps that have to run here. So as you can see, most companies who are developing in smaller user devices like phones and tablets have not used an Intel processor because it simply consumes too much power. They have gone to an ARM-based technology. They've licensed that technology. They've modified it, added cores, made other modifications, added graphics processors, and then use that as the basis on which to build a phone or a tablet or some mobile device. Now Microsoft has not quite followed that type of model. So you see that Apple has made quite a distinction between its mobile device OS and its desktop. What Microsoft has done has been to come out with a new operating system which they call Windows RT. And Windows RT has a new type of desktop, and if you've seen Windows 8 and seen the new desktop, that is the RT part of Windows. So you can almost think of Windows 8 now as having a dual identity. So if we look at this, this is Windows RT is part of a new tablet system called a Microsoft Surface. So if you had a Windows Surface tablet, and they cost about $500 for this type of Surface based on Windows RT, it would have an NVIDIA Tegra or an ARM-based processor. The operating system is no longer exactly Windows 8. It's a form of Windows 8, but it's modified, called Windows RT, and you'll notice that it has a little different user interface. These are called live tiles. Now Microsoft chose not to use the Windows Phone 8 operating system, although that operating system, if you have a Windows Phone 8, you'll notice that the interface looks the same, but underneath is a different operating system. And so we have apps that will run on this, but they need to be designed for Windows RT. Now, Microsoft also has Windows 8, for instance, and different versions, for instance, Windows 8 Pro, Home, or whatever. And part of Windows 8 is the typical desktop metaphor that you're used to. So if we look at how Windows 8 is now constructed, it has the normal Windows core services or kernel, but it's now in Windows 8 been broken up into two more modules here, and on this part it's called WinRT. Don't confuse that with Windows RT. This is a WinRT component, which is part of the Windows 8 operating system. And then we have the traditional Windows, we'll just call it the traditional Windows OS component here. Now Windows 8 can then run two different types of apps. It can run the a WinRT type of app, or what we'll call a normal desktop app. So in Windows 8 you might have an application like Adobe Photoshop. That would be a typical Windows 8 app, and so that would be the app here, would run on the Windows OS and the core, and would run on an Intel Core processor. The WinRT apps run on this type of interface. So what you'll notice that in Windows 8 now we have this desktop and we have this desktop we can get to. So we now have two types of applications. Microsoft has come out with a version of its tablet called Surface. So the tablet is called Surface, but you can buy the Surface with Windows RT, or you can buy a Surface with Windows 8 Pro. Now, Windows Surface with Windows RT can only use the RT style of apps. Now this desktop here, you may have heard the term Metro. At first Windows was calling this the Metro design, the Metro desktop. They got into some copyright issues and they can't use the term Metro, but many people know it by the Metro name. So some people call these the Metro apps. A Metro app, or an app designed for this new interface, will work on Windows 8, and it will run on Windows RT. So if you have a Windows RT Surface. The big point here is that if you have a normal Windows app like Photoshop or something that was designed for Windows, it will run on Windows 8 Pro, but it will not run on Windows RT. So if someone buys a Surface with Windows RT and think they can run any Windows apps, they can't. And so there has been some confusion on what applications will run on what form of Windows. So here Windows 8 now has a newer design. It has broken up the operating system to allow two different style of apps. It looks like Microsoft is moving towards the WinRT style of apps for its desktop operating systems as well as mobile platform. Interestingly, Windows Phone 8 is different. So applications, I'm actually not sure if the Metro apps here will run on Windows Phone 8 or if they need their own apps. When you go to buy apps, you can buy apps from the Windows Store. You'll notice that apps have a new designation. You'll find that apps that you can purchase have a designation often of i86, meaning they'll run in a 32-bit version. i64 means they'll also run in a 64-bit, and then you may see the letters ARM, meaning it will run on an ARM or a Windows RT operating system. So if your app that you purchase has these designations, it will run on any of the Surface devices. However, if your app just has one of these two designations, it will not run on the Surface Windows RT. So hopefully that's made it a little clear of the difference between Windows RT, Windows 8 Pro, and given you a little bit of a understanding about how any computing platform is componentized, and how the hardware and the operating system work together to run various apps.